Hello again, it's Mrs. Tremblay with the second lesson in Chapter 13, Product of Powers Property. So product, yes, it still means multiplication, nothing has changed. And we just learned in our last lesson what a power is. It's basically an exponential expression. There's a base and an exponent. And we're going to learn some special little properties that take place when you're multiplying powers. We're going to start out by looking at powers with the same bases. So with this first example here, it says, to multiply powers with the same base, bring over the base and add the exponents. And it sounds so easy. And again, it's kind of like when you learn to add integers. It sounds so easy when you have one thing presented to you. And then when you get a whole bunch, it gets kind of confusing. So for each property, I am going to show you how it works so that if you forget the rule, you can go ahead and do it out the long way and you'll remember the rule after that. You only need to do it probably once or twice before it gets locked in. So when this says to multiply powers with the same base, that means this big number here, if you're multiplying two powers and the bases match, you're allowed to simply bring over that base in your final answer. So the base is 4, the final answer, the base is 4, and add up those exponents, and 2 plus 3 is 5. So 4 squared times 4 to the third is equal to 4 to the fifth. Notice this is product power, right? This doesn't work with addition, and we'll have explored those things in class together. It doesn't work with addition. So why it works, if you think about it, 4 squared, and then yes, I want you to write this, everything I write you write. 4 squared really means 4 times 4, right? And 4 to the third power, if I'm multiplying this, means I have 3 fours. So this represents my 4 squared. This represents my 4 to the third power. In our first lesson, we learned how to rewrite this as a power, right? When you see the same base written over and over again, multiplied by one another, you can bring over that base and you use an exponent to tell you how many you have, right? So see how this is 4 to the fifth power? All you really need to do, instead of writing this all out the long way, is say, oh yeah, I have 2 4s and another 3 4s. That means I have 5. So it really is as simple as when you see the same base being multiplied, bring over the base and add the exponents. All right, I wish I had my easy button home with me. I could press that right now. If you have one, press the easy button. So let's try a few. And all I want you to do, we're not evaluating right now. You're not solving any of these. You're just going to rewrite your answer as a power, meaning a base and an exponent. So for this first one here, I have 2 to the fourth times 2 to the fifth. All you need to do to rewrite this as a single base is bring over the base and add your exponents, 4 plus 5. I'm going to write that for this one so you know where it came from. I do want you to write that also. So this is 2 to the 9th power would be your final answer. I won't make you do it for every single one of them, but I want you to at least have that first one written so that when you look back to these later, you know where the 9 came from. All right, next one I have n to the 7th times n to the 4th. I know it's a letter, but it's still the same idea here. I have the same base. It's n. I bring over the base. 7 plus 4, it's 11. So n to the 7th times n to the 4th is the same thing as n to the 11th. Jump up to this one over here for now. We'll do these two, and then we'll do the ones where the bases aren't exactly the same. So here I have negative 3 to the 5th times negative 3 to the 4th times negative 3 to the 3rd. My base is in parentheses, so I should have said quantity of before each of those. My apologies. All right, it's okay that I have 3 of the same base. It's all multiplication because this works when you have products. So I'm going to bring over the base, and now I have 5, 4, and 3. So I'm going to take 5 plus 4, which is 9, and 9 plus 3 is 12. So the quantity of negative 3 to the 12th power is what you would have. All right, right here, I have the same base. This one's a little tricky. Maybe you can already identify what's a little bit different about this one. A lot of people will tell me that, oh, this is 5 to the 10th power because 7 plus 3 is 10. But don't I have a 5 right here? How could I write this number as a power? You know how if I had 5 and I said, write that as a fraction, you'd say 5 over 1? Well, if I just see a plain old number 5, it really means 5 to the first power. Because doesn't the exponent tell me how many 5s I have? Yeah, and I have 1. So if you don't see an exponent, there's really a 1 there. You just drop that. Just like you don't put a little tiny addition sign in front of a positive number. You don't have to put that exponent there, even though it is there. So the moral of that lengthy story is for this one, it wouldn't be 5 to the 10th power. It would be 5 to the 11th power because that 5 still counts. All right, now jump down to this one right here. And when we were evaluating in lesson 3 or 3.1, not evaluating, rewriting, you saw when you had more than one base, you could still put the ones that had the same base together. We're going to do the same thing with that. This is still all multiplication. Here, I have the same base. I have 2 to the 3rd, I have 2 to the 4th. So those can go together. The base is 2, and the exponent would be 3 plus 4, which is 7. I'm supposed to multiply that by, there I have another set of matching bases. 4 to the 5th times 4. And we're allowed to mix up the order that we multiply numbers, right? This is an example of the commutative property. I'm moving around the order of the add-ons. So 4 to the 5th times 4, my base is 4. And remember, it's not 4 to the 5th power, it's 4 to the 5 plus 1, because that 1 is implied. So your final answer for this one should be 2 to the 7th times 4 to the 6th. If you wrote 4 to the 6th times 2 to the 7th, that's okay too, because of the commutative property. All right, and the last one like this, I have A's that match, and we have C's that match. So when we put all of our A's together that are being multiplied, we bring over that base, and 3 plus 2 is 5. And here I have C to the 5th times C. Again, don't forget that 1. And I have C to the 6th power. And this is another one where if you wanted to just write A to the 5th, C to the 6th, that means the same exact thing. Either one of those is fine. So if you see an expression written without a multiplication sign, if you see those letters next to each other like that, those little letter powers, it means that you're multiplying. So that's one product rule, that if you're multiplying powers with the same exact base, you can bring over the base and add the exponents. There's actually another rule here, and it's called raising a power to a power. When you raise a power to a power, and that will look like this. I'm going to cover this part up so you can just see it. This is 3 to the 4th power raised to the 3rd power. So power to a power, I see that I have these two exponents just separated by parentheses there. So I'm raising a power to another power. I don't have a repeated base in this expression. It's not 3 to the 4th power times 3 to the 3rd power. It's just the power to the power. That's why this is a little bit different. When you're raising a power to a power, all you have to do is keep the base, and now this time instead of adding your exponents, you're going to multiply them. So 3 to the 4th power to the 3rd power, I'm saying power a lot. 3 to the 4th power to the 3rd power is the same as taking 3 to the 4 times 3 power. So 3 to the 4th to the 3rd is equivalent to 3 to the 12th. And I'm going to show you why it works, because I have to show you how it works. I want to make sure you have an understanding of these, that you're not just memorizing. With the other one, when we wrote that out in expanded form, I'm going to scooch this for a minute, we rewrote 4 squared as 4 times 4, and we wrote 4 to the 3rd as 4 times 4 times 4. And we saw, oh yeah, I have 4 to the 5th power because I have 5 4s. If I were to start off writing this in expanded form, if you have 3 to the 4th power to the 3rd power, this exponent tells me how many of those I have, right? So initially, it would look like this. I would have 3 to the 4th times 3 to the 4th times 3 to the 4th, right? Now, you can look at this as, okay, I'm repeatedly multiplying the same base, so bring over the base 3 and add the exponents, 4, 8, 12. Or we could even take it a step further. If you have 3 to the 4th power, doesn't that mean that you have 4 3s? Right? So this represents your first 3 to the 4th power. And now I have it again. I have 4 3s. And now I have it again. I have 4 3s. And at the very end, you can see how many 3s you have. You should hopefully have the same amount I do. There's the first set of 4, the second set of 4, the third set of 4. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, yes, it's a little bit easier to just know the rule that, hey, if you're raising a power to a power, just take the 4 times the 3. You don't need to write all this out. But if you're taking a test and you forget what the rule is, if you wrote it all out, it would refresh your memory and bring it back. So for the next problems that follow, you'd be able to follow that rule. So should you have all that written down? The answer is yes, you should. Maybe you need to hit pause and go back and rewrite it all, but you need to have it all down. All right, so let's simplify some expressions with this. Okay, I have 5 squared to the 3rd power. This is not where you'd add them because it's a power to a power. I don't have a repeated base, so I'm going to bring over the 5, and here I'm going to multiply the 2 times the 3. And yes, for this one I want you to write that. Please do. So you know where the 6 came from. So 5 squared to the 3rd is equivalent to 5 to the 6th power. All right, let's try another one. Scooch it over. I have the quantity of -4 to the 5th power to the 6th power. So I'm going to bring over my base. Yes, it needs to be wrapped in parentheses because that's how it started. And you just need to take 5 times 6, which is 30. So we brought over the base, we multiplied the exponents. All right, here's a letter. It's okay, we treat them the exact same way because this n represents some number. And I know that if I have any power to a power, I can bring over the base, and 9 times 2 is 18. And last but not least of these, I have 3/4 cubed to the 4th power. And fractions, it works the exact same way. I'm going to bring over that base and multiply my exponents. 3 times 4 is 12. So again, if you see that you are raising a power to a power, all you need to do is bring over the base and multiply your exponents. And that's it. All right, turn over your page. Moving right along. Raising a product to a power. So this time, instead of just having one single base inside there or any repeated bases, we're going to have an expression that we actually need to simplify and evaluate when we can. All right, so here's how this works. Basically, if I have the quantity of 2x to the 3rd power, this right here isn't in simplest form because expressions that are in simplest form don't contain a math problem within it in parentheses that you'd have to solve. So if you see parentheses with a multiplication problem inside, that means it's not in simplest form. I need to get rid of those parentheses. So basically, to get rid of those parentheses, all you have to do is take each factor and raise it to the 3rd power. So this really means 2 to the 3rd power times x to the 3rd power. And when I say that you can evaluate the known values, well, we know 2, right? I don't know what x is, but I can figure out 2 to the 3rd power. It's 2 times 2 times 2, which is 8, times x to the 3rd power. We can't evaluate x to the 3rd power because we don't know what x is. So my final expression, you could write it as 8 times x to the 3rd power, or we could just write it as 8x to the 3rd power. The reason this works, because of course I want you to understand the reason, when you see 2x to the 3rd power, that means that you have 2x 3 times, right, that you're multiplying. And another way to look at this is 2 times x times 2 times x times 2 times x. When you multiply a whole bunch of numbers, does the order that you multiply them matter? No. So in this, I can go ahead and multiply my 3 2's. 2 times 2 is 4 times 2 is 8. And I know that when I repeatedly multiply the same base, I can bring over the base and add my exponents, which this would be a 1, and a 1. It'd be x to the 3rd power. So if you forget, you can always write it out in expanded form and arrive at your answer. So we're going to try a few. And directions say simplify the expression. So by simplify, I mean get rid of those parentheses. The only parentheses I can see are parentheses that are around a negative base and it's by itself in there. And when I say evaluate the known values, I mean for expressions like 2 to the 3rd power that you can find the value of, find those. For expressions like x to the 3rd power, we don't know what x is, so we can't find that. I'm sure it'll become more clear after a few examples. All right, so this first one, I have the quantity of 3y squared. This means take 3 squared and multiply it by y squared. So I'm taking each factor inside and raising it to that power. Well, I know what 3 squared is. It means 3 times 3, which is 9. I don't know what y squared is, so I'm just going to write the y squared. You can write them right next to each other just like that. Numbers next to letters, that means multiplication. So we have simplified this expression because we got rid of the parentheses. There's not a math problem inside parentheses anymore. The next one, I have the quantity of xy to the 5th power. This means x is being raised to the 5th power, and I'm multiplying that by y to the 5th power. Now you can leave it like that if you like. You could also drop the sign and write it just like that. They both mean the exact same thing. I think most of the time you see it without the multiplication symbol. All right, next one, I have the quantity of 5y to the 4th power. This means 5 to the 4th power times y to the 4th power. So again, each one of those factors, numbers that I'm multiplying together, is being raised to the 4th power. Now we can figure out what 5 to the 4th power is. 5 to the 4th power means I have 5 multiplied 4 times, right? So 5 times 5 times 5 times 5. Any idea what that is? I might take 25 times 25. Once you do that, you'll get 625. So I can evaluate 5 to the 4th power because I know what 5 to the 4th power is. You can't evaluate y to the 4th power because we don't know y. So I'm just going to rewrite that. That would be my final answer. That's, again, is simplified because it doesn't contain any parentheses. All right, next one. I have decimal in there. It's okay to have decimals. And this means I want to raise 5/10 to the 2nd power and n to the 2nd power. We can go ahead and evaluate 5/10 to the 2nd power. It's 0.5 multiplied by another 0.5, which is 0.25. I can put the 0 there, why not? And we can't evaluate n squared because we don't know what n is. So that should be your final answer. 2 left, we're almost there. All right, in this one, I have the quantity of negative 3x to the 5th power. So this negative 3 is inside parentheses inside here, so I'm going to write negative 3 to the 5th power in parentheses. I'm multiplying that by x to the 5th power. So again, this quantity of negative 3 to the 5th power means you are multiplying negative 3 5 times. What happens when you multiply 5 negatives? What happens when you multiply an odd number of negatives? Yes, you get a negative. And when you take 3 times 3 times 3 times 3 times 3, do you know what you get? Are you talking to yourself? I am too. You get negative 243. I sure hope that's what you get. I'm pretty sure. And I don't know what x is, so I'm just going to rewrite that x to the 5th power. That multiplication is implied when I write the number right next to the letter. Last but not least, a lovely little fraction here. I have the quantity of negative 3/4 y to the 3rd power. This, of course, means I want to raise negative 3/4 to the 3rd power and y to the 3rd power. When you take negative 3/4 to the 3rd power, it means that you are multiplying negative 3/4 3 times. So if I have an odd number of negatives, yes, you guessed it, my last expression is going to be negative, multiplying across the top. 3 times 3 is 9. 9 times 3 is 27. 4 times 4 is 16. 16 times 4 is 64. So this portion here I can evaluate because I know the value of negative 3/4 to the 3rd power. I can't evaluate y cubed though, so I'm just going to rewrite it right next to it. We're done.